not all introduced.
Oh, okay.
Hello, everyone. Welcome back. We're very sorry for the disruption. We had a bit of connectivity issues. But we are back again with Dr. Karen Draths, and here she is.
All right, everyone. Sorry about that. I just kept talking and talking. I didn't even know we were not connected. All right, so thank you, Emma, for getting me back on. All right, so this is a map of the U.S. shale gas. So as I said, our goal is to move away from using sugars as a feedstock for our microorganisms that we're then programming to make chemicals. And so with this map, you can see where the green splotches are. That's where there is a lot of horizontal drilling going on. And with that horizontal drilling, we're getting a lot of natural gas and methane. So methane is CH4, which is the most basic hydrocarbon, the most basic organic chemical you can get. And so what we want to do is we want to use methane as the carbon source to make our organic molecules now. And just to point out, methane, you may have heard, there's a lot of problem with gassy cows and things like that. Methane is a pretty bad greenhouse gas. And in fact, up in North Dakota in the Bakken fields where they're doing a lot of horizontal drilling, they're actually just flaring off a lot of methane. So in other words, we don't want methane just going out into the atmosphere. And so what they do is they light it on fire and they burn it. And so when we do that, we're wasting a lot of methane, all right? And so our goal is to use that methane by being able to give either methane or some modified form of methane to our bacteria. All right, this is a map. You can see here's North America, South America. You can see these colored areas off the coasts of most of the continents, okay? And what these represent are reserves of methane hydrates. So essentially, underneath the ocean floors around the continents, there are reserves of methane that are deep down underneath the ocean. And while basically the form of that methane, because it's under very high pressure and it's very cold down there, it's basically like methane ice. I'll show you a picture of that in a second. And so what we're saying is the amount of methane that's here on the earth is huge compared to the amount of say glucose that we can grow every year. And so we'd like to be able to tap into these methane hydrates in order to make chemicals. All right, so just to give you some crude numbers here. So proven methane reserves in the US are 81 trillion cubic meters. That's a lot, okay? The U.S. Chemical industry uses less than 0.1 trillion cubic meters per year. So this is a huge amount of methane that could be tapped into, and that's why we're trying to develop our microorganisms to use methane. And so methane, and this is a picture of methane hydrates, okay? That's that frozen ice methane. We also have renewable ways of getting methane. As I told you, that we've already got our gassy cows. That's methane that's hard to trap. But there's all sorts of waste that you can get. So this is actually a picture of dining hall waste. There's waste from cornfields and farming, organic waste, and then organic waste from animals, and we can put all that stuff in an anaerobic digester, and here we'd have lots of different organisms in there, and those are going to chew up these organic wastes and they spit out methane. And this is something that's already being done here at Michigan State. This anaerobic digester is actually a picture right here on campus at MSU. And so the goal of our current research is to transform our bacteria or use different bacteria and to try to encourage them and design them such that they will use methane or molecules that we can get directly from methane as a feedstock instead of using glucose. And so here I just want to give you a very quick pitch on the PhD program here at MSU. So if you guys are into science, you know, a lot of people who are interested in science go to medical school or dental school or some professional school like that. But, you know, oftentimes that costs a lot of money. And so I didn't have a lot of money when I graduated from college. And so instead of going to a school like that, what I did is I went to Stanford actually and got a PhD in chemistry. And just in case you weren't aware, most of the large universities in the United States, you can get what's called a teaching assistantship and a research assistantship. You can be a TA at a major university, and they will pay you to be a teaching assistant. So you work in a lab with some undergraduates that are taking a class, and then in the rest of your time, you're working on original research. So if you love to do original research, by original research, what's so cool about that is we do things in our lab every day that nobody's ever done before. And that's fun. And you can publish papers and you can give talks about it. So I just want to give you guys a pitch that, keep a PhD program in mind when you're in college, that could be a place for you to go after your undergraduate career. And so now I'd just like to give a brief thanks here to the science squad, especially to Emma. She's fantastic. I really appreciate Emma working on these technical difficulties with me because I'm not very techy. So thank you again for your interest tonight, and I wish all of you well, and good luck with the rest of your school year. Thank you.
And thank you very much for giving a presentation.